Welcome back. Today we will be talking about the geometric sequence and the series. So geometric implies the common ratio. So if you look at the numbers 12, 36, 108, what is the pattern that we can see? We can see the pattern is 12 times 3 and then 36 times 3. So the nth term, an, can be written as the first term times the common ratio to the power of n minus 1. And the same can be achieved if I divide the second term by the first term. We are getting the common ratio as 3. So writing as any term starting with the first term times the common ratio to the power of n minus 1. That means what term you want to calculate. That is called the explicit way of writing the geometric. There is another that is called the recursive, that is based on the previous ones. So let's find out the common ratio first. So the numbers are given 5, 15, and 45. So I can either look at the multiplication, what times 5 is 15, or what times 15 times what is 45, or you can divide 15 by 5 and you will get the common ratio as 3. If I use the explicit way, that means an is equal to the first term times r to the power of n minus 1, I will be able to calculate the 12th term because n in this case is 12. So we are replacing n with 12. And if you plug it in, all the information correctly, remember a1 is your first term is 5, you will get the 12th term something like 5 times this big number, that is 885,735 will be your 12th term. Remember, again, sequence implies the next term, the terms. Series implies the summation of all the sequences. Now this question is a little bit different. We don't have the first term, we have the second term and the fifth term. But we also know that an is nothing but the first term times r to the power of n minus 1. But we don't have the first term, so we are starting with the fifth term. So fifth term will be based on the previous term. So the previous term we are taking a2 because a2 is given. And I can do n minus 2, n in this case is 5, so 5 minus 2. Because we did a1 with the first term, we did n minus 1 because that was my first term. So the term should match with the subtraction. So in this case, let me repeat it again. We were starting with the second term. So I will do n minus 2 because the term is second. So if I do all the calculations, because a fifth is given as 81 fourths, and then going backwards for solving for r, you will get the cube root of 81 over 24, which is nothing but 3/2. Okay. Now let's go with the eighth term. A8, I can start with A5. Because we are starting with A5, we will do n minus 5. So I know the fifth term is 81 fourths, r to the power of 3. You just calculated r to the power of 3. So r to the power of 3 is 81 over 24. I can plug it back in the equation to get my eighth term. So every question will be a little bit different, but the pattern will remain the same. The explicit approach or the recursive approach. So your number will be 2187. Now let's talk about the sum. When we do the summation, we use the sigma notation. So the summation from I is equal to 1 to n. Again, we are starting with 1. If it is not 1, then we need to make it 1. First term times the common ratio to the power of I minus 1 can be written as the first term times 1 minus r to the power of n divided by 1 minus r. So lower bound is 1 and the upper bound is lower bound and the upper bound. They should be defined. If lower bound is not 1, I need to make it 1. So in first example, the lower bound is not 1. The lower bound is 0. How to make it 1? Let's add 1. So as you can see, n is from 0 to 20. I need to make 0 into 1. So make it 1 to 21. So I will add 1 to 0 and then 1 to 20. And then we can write the new summation rule as n is equal to 1 to 21. Now this will be my equation. Again, we added 1, so n will be subtracted with 1 because my equation is n minus 1. That is my pattern, I minus 1. This should be in the same format of the summation. So we know I can use the first term, a times 1 minus r to the power of n divided by 1 minus r. Be careful with the fraction. You need a calculator to solve what is 3/2 to the power of 21. Right? So if you simplify it, you should get the approximately something 2 point, it is 29,921.33 or 311. Right? So again, the rule of thumb, if the equation is not, the lower bound is not 1, make it 2, 1. Now let's talk about what will happen when we, in the previous case we talked about the finite. Now we have the infinite. So infinite is also called as simple as the geometric series. So we are looking for the assumptions that the absolute value of r, that means absolute value of the common ratio, should be less than 1 as n approaches to infinity. Then we are looking for something that a1, that means the first term, divided by 1 minus r. If the absolute value of r sorry, is greater than 1, then it will diverge. Then it implies that we cannot find the sum. So first thing that you need to calculate is always check the absolute value of r. If absolute value of r is less than 1, okay, it converges. I can find the sum. If it is greater than 1, then stop and just say diverges. So in this case, the common ratio r is given as 1/2 and 1/2 is less than 1. So I can go ahead and find the summation. Summation for the infinite is very easy. It is just the first term divided by 1 minus r. For the finite, we need to do more work. 1 minus r to the power of n divided by 1 minus r times the first term. But for the infinite, you need to check the common ratio first. So I was able to calculate the answer as 32. Now, geometric sequence. Let's try. The first question, they are asking for find the nth term. So we need to calculate r first. So if you look at the pattern, r is 1/2. So I can say r is equal to 1/2. And a1 is 2 because we are starting with 2. After that, we need to find the nth term. So I can say an is equal to 2 times 1/2 to the power of n minus 1. So when they are asking for the nth term, they are saying, give me the equation, right? Or give me the formula for this particular problem. So we have the formula for this particular problem. Now, the second part of the question, they ask for the 12th term, sum of the first 12th term. So the 12th term, I need to calculate what is the value at 12. So n is 12, I know a1 is 2, and r is 1/2 from part A. So I need the sum of the 12. So S12 will be a1 times 1 minus r to the power of n divided by 1 minus r. Because they are asking for the 12th term, we are finding the sum of the finite, because 12 is a finite number. So your approximate answer will be 3.999. And make it a rule of thumb. Always write decimal places, 3 decimal places. It will help you in the calculus as well. Let's take one word problem. Now in this case, they are saying that you are saving $10 a week from your paycheck and you are depositing in a saving account which is earning 1% rate of interest. How much will you save in 1 year? How much? So first thing first, 1 year implies 52 weeks. So 52 implies it is a finite. That means the sum of the finite. So I have a finite formula here. A1, that means the starting is 10. Now, rate is not 1. You are earning 1%, right? So 1% is 0.01, and that is your earning on 1. So it will be 100 plus 0.01. So the rate is 1.01 because it is your earning. So 10 times 1 minus 1.01 to the power of n, which is 52 in this case, divided by 1 minus 1.01. If you were not earning, if you were losing, then we would have subtracted 0.01. So we can write our final answer as $677.68. Let's summarize everything and understand the difference between the geometric and arithmetic in detail. So this is how I sort them out. So if you look at on the left hand side, we have the arithmetic, the explicit formula, the recursive formula, and how to find the summation. On the right hand side, we have the geometric listed. Explicit, recursive, but in geometric we have a different condition for the sum of finite and this different for infinite. For the finite, we are saying that r should not be equal to 1, but for infinite, we are looking for divergence and convergence. So the series will converge, or we will be able to find the sum if it is r is less than 1, absolute value of r. But if the absolute value of r is greater than 1, then it diverges. To summarize it, the function that best fits an arithmetic sequence is the linear, but the function that best fits the geometric is the exponential. I hope it made sense. I will see you in the next video.